Okay, so today, well, I guess let's back up. Yesterday, I can't find my pen. Oh, there it is. Yesterday, we did the idea of graphing, right? Graphing's probably not the best way, honestly, to solve a system of equations. Okay, so why did we do it? All right, because I'm a terrible person, right? That's what you want to say. No, right? We did it because visually it makes the most sense. Like we can actually see where those two lines cross place, right? What that ordered pair is that they share in common. Okay. Today we're going to look at it algebraically. So we're actually going to solve the equations to find that answer. It's a little more abstract as far as finding the result, but if we already know how it works graphically, hopefully this idea should make sense. Okay. So we're not going to be graphing for a multitude of reasons. Can you tell me one reason why graphing maybe is not the best idea? Give me a reason. Sure. If you don't even have a graph paper, that's a problem. Yeah. What? Yeah. Sure. What if it was a decimal? Like, how are you supposed to even find that result? Right? How many of you don't even like to graph? Right. So, so there's a lot of reasons why graphing maybe is not our best option. Okay. So we're going to look at a method today called substitution. All right. And if you substitute, that means you are replacing something inside of the problem. Okay. And so that's going to be kind of our plan of attack today. So we're going to look at 4 questions today. That's it. Give us an idea of how this works, and we'll practice it to more tomorrow in class. All right. So can we solve systems by substitution? That's our goal for today. This second one, the real world piece, we're going to use tomorrow in class. So we'll kind of extend that second piece in tomorrow. Today, we're just going to try to get the basics of how does substitution work. All right. So we kind of talked about this. Graphing is not always our best option. It's great if you're just trying to get an idea of where something is at, but as far as like an exact solution, it kind of leaves a lot to be desired. So substitution is a way to basically do this, to reduce your 2 equations and turn them into one. All right, and I'll show you what that looks like so we can get the idea. All right. Everybody in this room, I firmly believe this. Everybody in this room can solve this problem. Right? Don't shake your head. No, you can solve that. How many moves to get an answer to that? I don't know if 2 moves, right? Ben, what would the first move be? Subtract 12. The last move would be to good. Regardless of whether that comes out to be a whole number or a decimal, we can do it. All right. Why we can do it? Because there's only one variable in this problem. Because there's only x's in this problem, we could do it. Even if I added an x to the 12, you still could do it. Right? We would combine the 12 and the 3 together. We would divide both sides by 15. We could still get an answer. Right? Okay. But if this variable is not an x, and let's say it's a y, can you get an answer now? Really? What would it be? Okay. Uh huh. Okay. Okay. So we could solve for a variable, right? We could make this thing say y equals or x equals, but could we get an answer, a number? Why not? Because I have 2 variables, right? And if I have 2 variables, I can't solve. I could guess numbers that fit in for x and fit in for y and try to make them equal 40, quote, an ordered pair. All right. But I couldn't actually figure out what the solution was here because, well, there's 2 things that I don't know. So in a system of equations, we actually have 2 equations. And the reason we have 2 equations is because we have 2 unknowns. We don't know x, we don't know y. 2 unknowns, 2 equations. If there were 3 variables, do you know how many equations you'd have to have in order to be able to solve it? Listen, when there was 1 variable in this problem, you guys could solve it. 1 variable, 1 equation. When there's 2 variables, you got to have 2 equations. When there's 3 variables, you got to have 3 equations. If there were 5 variables in a problem, how many equations would you have to have in order to be able to solve it? 5. Okay, so realize that those 2 things are tied together. All right. So everything we look at today is going to have two equations because there's going to be 2 things that we're trying to find. Now, these steps that we're going to go through here, they're going to be on every screen that we look at. So don't feel as though you got to maybe write them all down right now, but we're just going to kind of talk through them, and then we're going to practice this idea. All right. When you solve a system by substitution, step number one is probably the most important, but maybe not always necessary to be done. As crazy as that sounds, right? We've got to do exactly what you just said when you were trying to solve your equation for y, like move the x to the other side, divide by 12, right, to get y by itself. We're going to solve an equation for a variable if we have to, not for an answer, but just for what we call a resulting expression, like basically, the mx plus b maybe side of things, okay? We're going to take that and we're going to plug it into the other equation. That's why the name substitution comes into play. So if you think athletically, like if I take somebody out of the game, how many people do I put in? Just one, right? I can't take one guy out and put two guys in, right? It's got to be an equal trade of what goes in and out, okay? So when I substitute today, that's what I'm going to do. I'm going to take something out and I'm going to put something in its place, all right? When I do that, I'm going to solve what I get, and you'll see how that works. That's going to give me part of my answer. Then I'm going to have to find the other part, meaning I'm either going to find the variable for x or I'm going to find the variable for y. But remember, my ultimate goal is to find the ordered pair that they share in common. Or essentially, think about their lines. I'm trying to find that point where they cross paths with each other. Okay, so that's why we graphed yesterday, so that you could visually think about those lines crossing paths. Today, we're going to look at it algebraically. All right? Lose the eyes. You'll be okay. All right? You give me them concerned eyebrows. I see them. And we'll be all right. Here we go. So we're going to look at 4. So, like I said, these are going to be here on every screen. So if you want to write those down, you'll be able to see them. Okay. Now, as I look at this right now, one of those equations is already solved, like y equals mx plus b. But graphing it would be a bad idea. How come? Why would graphing it be bad? Look at it. Y equals negative 5x minus 17. Think about graphing that. Yeah, right? Your y-intercept's negative 17. Like just to start off, you have to go 17 units down just to start. And then the slope's negative 5. It's going to go further down, right? I mean, that's going to be bad, okay? So we're going to use a method called substitution to do this. So if you have not, please write those 2 equations down somewhere on your paper. Remember, so we're going to look at 4 of these. This is number 1. Okay. You're going to find with the method of substitution, it's very repetitive. Like it's going to be the same idea. Now, step number 1 here says you need to solve for one variable in at least one equation. I don't have to do that here. One of my equations is already solved. Which one's solved? The top one or the bottom one? The bottom one, right? It already says y equals, okay? I am going to substitute the resulting expression into the other equation. Now, that sounds a little weird, but the resulting expression here is what it's equal to. So in this case, that is the resulting expression. So if you have not, would you please put a box around that statement? Okay. Now, this step says I'm going to substitute that resulting expression into the other equation. Where do you think in this top equation I'm going to plug that boxed response? What do you think?
Could you combine the negative 5x and then negative 3 and negative 17?
No, but I mean, you're thinking that idea of like terms, right? Like trying to put those together. This boxed expression is equal to what? No, it's not equal to 3. It's equal to y. It's equal to y, right? That's what it says it's equal to. So in this top equation, I am going to plug it in right there for the y because that's what it's equal to. So I'm going to substitute it into its place. Okay, good. So there you go. So negative 3x minus 3, but I am not going to write y. What is y equal to? The negative. Good. So instead of writing y, I'm going to write negative 5x minus 17. And that is equal to what? 3. Okay? Step 2 is done. Like, I have substituted it into the other equation. Look at the new equation I've created. What's not here anymore? Quinn? What is gone? Y's are gone. So that means you only have one variable. We can solve something that has one variable. Okay? So I've taken two equations and I've morphed them into one. And that one equation only has x's in it at this point. And now I can solve it. At this point, if you have both x's and y's, you screwed up. Okay? Something's not right. Because we can't solve that. But this we can. So we're going to distribute, combine, and figure out what x is equal to. So distribute the -3. So that's just make your distribution, combine your like terms, and you should get a value for x. Okay. I didn't see your negative in there. Yep. Good. Okay. Get x is equal to -4. So the x's were on the same side of the equation, so I just combined those together. But the 51 and the 3 were on opposite sides, so I had to inverse one of them to the other side. Step number 3 is done. Step number 3 said solve an equation and figure out one of your variables. I did. I found out that x was equal to -4. So remember, in a system of equations, we're trying to find the ordered pair that is a solution to both. Right now, I have found half of it. I know that the x value in this ordered pair has to be a -4. Okay? To find the other one, you have two choices. You can either, in step 4 says, you can substitute it back into either one of the original equations. One of them is a really good idea, and one of them is not. Kyler? Is good or bad? Okay. How many of you agree? How many of you disagree? Like that bottom one says what? It says y equals. That's the one I want because it will tell me exactly what y is equal to. Just plug it right into the bottom one. What is -5 times -4? 20, and 20 minus 17 is 3. So there's your answer. Okay. Step 4 done. Step 5 done because I wrote my ordered pair. The first part of this is where work is involved to find that first variable. Once you find the first variable, you get the second one for free. You just go right back to where you started, plug it in there, and you're done. Okay? Thoughts? Concerns? We're going to try it a couple times. I think you okay? Just think visually for a second. Like if I were to graph both of these, there is going to be some point that they share in common. All right, as long as they're obviously not parallel to each other or the same line, there is some point that they share. That's what we're trying to find. Okay? So very similar to this one. We're going to try this one. As you're writing that down, do I need to solve for a variable? Look at the top equation. because the top one already says what? It says y equals. If it says y equals or x equals, the first part's already done. Okay, so because there's an x and a y, I'm going to have to do something to both of them to figure out a solution. And so substitution allows me to be able to essentially plug one of the equations into the other one. Okay, I don't need to do this first step because there's a resulting expression already here. What in this problem should I put a box around? Quinn? There you go. That's what y is equal to. That's what I'm going to box. Yes, sir. Yeah. Yep, you're good. Now, I'm going to draw an arrow from this box to where? Where am I plugging it into? Kaylin? The y, right? Yeah, right beneath it. I'm plugging it in, maybe, right there. So I need to write a new equation that has both of them together. And it should say negative 2x minus 3. But I am not writing y. I'm writing 6x minus 11 equals negative 7. Okay. So you should only have x's in your problem at this point. Negative 3 times 6 is negative 18. Not negative. What? What? Negative 2. Okay, those are on the same side, so you should be bringing those together for negative 20. So once I'm able to write my new equation, I'm ready to now solve and figure out that value of x. If you can find the value of x, good, then you should then be able to figure out what the value of y is that goes with it. Good. So that's x. So can you figure out what y is? Very good. Awesome. So now if you know that value, can you tell me what the corresponding value of y is that goes with it? Good. Put those together. What's negative? That 18 has an x on it. Okay. So negative 2 and negative 18 is a total of negative 20x. Very good. Negative 40 and negative 20. That should be a positive 2. Negative 2 and negative 18 is negative 20. All right. So we're going to move the 33 to the other side. I'm also going to combine those two. That's negative 20x equals negative 40. Negative divided by negative becomes a positive 2. So x is equal to 2. So there's step 3. I know that x is 2. You have two choices. Plug it into the top one or plug it into the bottom one. One good idea, one really bad one. Not really bad, just more work. Like, which one should I plug that answer of x equals 2 into? The top one. The top one says y equals, and I want to know what y is. So it would make sense to take this right back to that box. So put a 2 in there. 6 times 2 is 12, and 12 minus 11 is 1. So there's my answer.
Manchester's doing the same exact thing right now.
Are they?
Yeah, because someone tried to make me do it.
She probably did. All right. Yep, the face said she did. All right. So you are always going to take your answer back to the box. Whatever you boxed to start with, that's where you're going to go. All right? Oh, like a mind reader, right? What if you can't? What if I told you we were going to do 4 questions, right? So this is number 3 coming right here. What if maybe? What if you look at a problem right now and there's not something that's solved? Who said skip it? Amen to that, right? Skip it, move on, right? We're going to solve for one of them. Okay? So we have 4 choices. We can solve for that x right there, or we can solve for that y, or we can solve for this x, or we can solve for that y. There's 4 choices. Okay? 3 of them are bad, 1 of them's good. Now you look at those 4 variables for a second and you tell me 3 of them look very similar and 1 of them looks different. If I'm telling you 3 are bad and 1 is good, you got to be able to tell me which one is the good one. You might not know why, but you should be able to tell me which one it is. All right, Andrew, which one do you think it is? The top y? Okay. Quinn, what do you think? The lonely X. I like the fact that you called it the lonely X. Ah, there's what? There's nothing next to it. It has no what? What's that called? Has no coefficient, right? Which means that if I want to solve for it, all I have to do is move what? Move the negative 2y. And how do you move something to the other side? You either add it or you subtract it. There you go, right? If I move this 2y to the other side, it simply becomes 2y plus 11. And I box what part of it? There you go. So if you look at this right now and say, man, nothing is solved, you find the easiest one to solve for. And I'm telling you, the easiest one is if there's no coefficient. Okay? Now, if there is a coefficient on all of them, guess what? We ain't using substitution. There's another method that we'll talk about next week. Like, it's not worth it. It's not worth the hassle. Okay? Because when there's a coefficient, you'll have to divide. Right? And like, look at the top one, a 7, a 2, and a 13. Do any of those numbers play nice? Not if you're trying to divide, they don't. So now you're talking about having decimals and like, could you do it? Sure. Do you want to do it? No. All right. Now here in this top equation, I'm about to take this boxed response and plug it in. But where am I plugging it in? I'm plugging it in for the x because this one says x equals. So now it goes over there where x is because that's what the equation is equal to. And now the repetitive nature is going to kind of set in because I'm going to rewrite my equation. Okay. Step 1 is done. I solved. Step 2, I'm going to substitute right now. Negative 7. But now I'm going to write 2y plus 11 minus another 2y equals negative 13. My new equation has no what? No x's. All y's, I can solve it. You already have it? Very good. What's that? Oh, because I'm a genius. What if the whole thing's a lie? The whole world. Right? I'm going to distribute.
What the heck?
What now?
I keep getting decimal.
That 13 is negative. But all of a sudden here it became positive.
Oh.
You just lost it along the way. Now, just because you, okay, decimals are allowed. They're real numbers. They're answers. For now, for our sake, they're not going to be solutions. so that we can kind of keep track of whether we're doing something right or not. So if you do get a decimal right now, you're wrong, but that doesn't always mean that you're wrong. All right, so negative 14y minus 77 minus 2y equals negative 13. Add the 77. These two are negative 16y equals 64. Aiden, what's up? So in this case, it's y is equal to negative 4. So that's your y value this time, not your x value. Okay. Now, just like every other time, you've had two choices. You plug it into the top one, you plug it into the bottom one. Okay, which one am I plugging it into? That's a solid idea because the bottom one says x equals. So take this answer of negative 4 and go right there to that box. What's 2 times negative 4 plus 3 more, or 11 more? 2, it is 3, right? 2 times negative 4, that's negative 8 plus 11. I said the answer and not plus 11. That was on me. Okay. So I'm going to take that answer of negative 4. I take it back to where I started. It will give me my other variable. What? No. Listen, get your question answered. What's up? Oh. Oh. Uh-huh. Oh, okay. Okay. Yep. All right. So the only way it could get worse than this is if all 4 of those variables had coefficients in front of them. And if that was the case, we wouldn't substitute.
Are you going to give us the next one?
Yeah. No. Because so the next one's going to look very like you should look at that right now and say, I'm solving for the top y. If they all have variables with numbers, coefficients in front of them, we're not substituting. There's another method that's going to make it easier for me. Okay. But for right now, that's the variable I should be isolating because it can easily become something by itself. How do you get the y by itself? Add 5x to both sides. All right. So we are going to put a positive 5x over here, and that is not there anymore. We just add it to the other side, and we get the y by itself. Okay? So box, substitute, see what you can come up with, and then we're done for today. And we'll kind of work this in class tomorrow. Well, so this is an algebraic method to it. We're not, so yesterday was graphically, like we were looking for a solution. We did that yesterday because I wanted you to be able to visually see what you were going for. Had we started right here, you guys have been looking at me like, what? And like, what? Some of you are still looking at me that way, right? But hopefully you're starting to put those two thoughts together. Graphing's at the bottom of my list, for sure. Is it?
Yeah.
Now listen, if I use Desmos, it's at the top of my list. But if I got to do it by hand, it's at the bottom. Oh, for sure. I don't think it's harder. It's just, yeah, it's time consuming. Like I got to have graph paper. I got to solve for y. I got to find the intercepts. Like I could do it a lot quicker elsewhere. I mean, personally. But to each their own. Like, I mean, it's not. Eh. No, you are not getting a decimal to this one.
I have both variables.
Okay. The 6y is not there. Look, if you box, it's going right there. You had an extra 6y there. Remember, if you write your combined equation and x's and y's are still both there, you're in trouble. Like you screwed up. So,
negative 12.
yeah, it's not a 2. What? Where you at?
So far.
Like, you lost your
Oh.
equals and then just phantomly put a new one back in there.
So
Like, this is fine, this
Yeah.
step right here, but that should be equal to negative 12. Erase that. Get that out of there for a minute. No, that step's fine.
Oh,
It's,
this right here.
yeah, get rid of that stuff. This stuff right here. And get rid of that. And this is equal to negative 12. Okay. So those two together are negative 15.
Mhm.
Or no, I'm sorry.
Oh wait, that'd be positive, right?
These are your two like terms here and here. So negative 27x minus 12 equals a negative 12.
Oh, okay.
All right.
So like the beginning, not like
Uh-huh.
Okay.
And then it's equal to what? Negative 12 plus 12. 0. You got it. Very good. Oh,
No, I did something
that's
wrong.
right. But then when you plug that back in here,
Oh,
that's gone.
that's just 10.
Should be a negative 2. You got them flip-flopped. Look, x is 0, y is negative 2. Flip your order. You wrote your order pair backwards.
No, it goes XY.
It goes x, then y. Yeah, it goes x, then y.
What did I?
Nothing. Divide both sides by 27.
You can't.
Yes, you can. What do you mean you can't?
27 divided by 2.
Very good.
0
Try again.
divided by
Very
7
good.
is 27.
So negative 3x minus 12 plus 30x equals negative 12. If you add 12 to both sides, they both cancel. My like terms right there give me negative, oh, sorry. Try again. They give me 27x equals 0. Divide both sides by, yeah. Divide both sides by 27. 0 divided by anything is 0. So there's half your answer. Half your answer is guaranteed to be a 0. And then take that response and go right back to the box that you started with. So you have negative 2 plus 5 times 0. That is negative 2. I think originally, if I remember looking, you did not have a negative 2 here. I think you just had a 2. Uh-huh.
Negative 3x times 5x. You got 15x and solved it the rest of the way that way, but I still got the same answer.
Well, only because this was a 0. Any other number and that would have been off. So be careful there. All right. So that's where we're going to stop for today. Okay. We will work on this in class tomorrow, and then we have a couple word problems that we're going to do along with this tomorrow.